Hi, my student, is Darasa Online again. You'll be with me, Kimati, a teacher from Jangwani Secondary School. I'll be sharing with you today a topic so-called algebra, and subtopic will be a series as it is seen on your screen out there. So please be with me as we go on trying to remind ourselves on series. So today we will cover the following. First of all, we shall see the definitions of terms, then we shall define a series, a finite series, infinite series, and these two are the types of the series. And then we shall see a sigma notation, and then after that we shall use the sigma notation when writing series. So we shall use sigma notation in writing series, and then after that we shall find the sum of first n terms, and then we shall find the sum of first n square terms of the series, and then after that we shall find the sum of the first n cubic terms of the series. So be with me. Definitions. A series is a sequence of terms, each of which can be written in a form that is an algebraic function of each position in a series. That means the position of the term in a series is an algebraic function of itself. Example, we have 2 plus 4 plus 6 plus 8 plus 10. As you can see there, the first term is 2, the second term is 4, the third one is 6, the fourth one is 8, and so forth and so forth. Now that means a 2 where it is an algebraic function of its own position. Then we have a 4, that is the second term. So 4 is an algebraic function of itself at that position. We shall see it as we go on in some few examples, in some few next steps. Now let's see types of series. As I said earlier, we have finite series, or sometimes it do pronounce finite series, is a type of series in which terminates or each term can be counted. That means in finite series you can count down the number of terms. If there are 10 terms or 15 terms or 6 terms, whatever, but you can count down the number of terms. But you can count down the number of terms. For example, we have 1, 2, 3, 4, up to 15. And if you try to look that much careful there, you will see the difference is 1. From 1 to 2, the difference is 1. And from 2 to 3, the difference is 1. That means if we try to list down these terms, we'll end up having 15 terms. We'll end up having 15 terms. So that means a finite series is a type of series in which the terms can be counted. Again, we have infinite series or infinite series. It's a type of series in which the number of terms does not terminate. That means you cannot count the number of terms. The number of terms is unknown. That is to say, it has uncountable number of terms. For example, we have a series that starts with 100, then 99, then 98, then 97, and so forth. But we don't have the end or the last term. As in the last example or last type, we had the last term, that was 15. But in this type of series, we don't have the last term. We don't have the last term. It just shows us it continues. That is infinity series. Okay, now let's go on with our definition and let's discuss what is sigma notation. A sigma notation is a letter that is used to represent summation of terms in a given series. We say sigma notation is a letter that is used to present summation of terms in a given series, and it is written as it is seen there. Now, for example, you have a series like this. We have 1 plus 2 plus 3 plus 4 up to n. Then we can sum them by the use of sigma notation. That means summation of r terms from r is equal to 1 up to n. Meaning that when r is equal to 1, that means we have the first term. And when r is equal to 2, we have the second term. We shall see as we go on seeing the next examples. Now, a sigma notation, as we saw, it is written like that. And we will use the following formulas as we go on. For example, we have a series like 1 plus 2 plus 3 plus 4 plus down to n. Then its summation will be like written as a summation of r terms when r is equal to 1 to n. That means the formula that is used to find that is summation of r from r is equal to 1 to n is equal to n over 2 n plus 1. That is summation of terms, terms when r is equal to that much, and we say this is summation of terms. We say this is a summation of any terms. Now, when terms are like this, when 1 square plus 2 square plus 3 square plus 4 square plus down to n square, then how can we write this in a sigma notation? It is summation of r square when r is equal to 1 to n. That means when r is equal to 1, we have 1 square. When r is equal to 2, we have 2 square. That means we go on. That means the formula for that is summation of r square when r is equal to 1 to n, and it is n over 6, n plus 1 to n plus 1. And when the terms are first n cubic terms, that means we are talking about this. In sigma notation form, how is it written? It's written like this. R cubic when r is equal to 1 to n. Now, its formula is the sum of cubic terms when r is equal to 1 to n equals to what? To n over 2, n plus 1, and all of these is squared, and all of that is squared. So these are the three formulas that will be used. That means this will be the sum of the first n terms, and this will be the sum of the first n square terms, and this will be the sum of the first n cubic terms. Now let's see how those formulas are used in finding the answers to different questions. So example number 1, write the following series in sigma notation. Write the following series in sigma notation. So we are given a series that says 1 plus 2 plus 3 plus 4 plus 5, and the difference there is 1 notation. So we are told to write that in sigma notation. So how can we handle that? Now, when you are in Form 3, you used it to have these formulas. For the nth term, you had this. And that means the nth term of the series is found by having the first term and then the number of terms minus 1 times the difference. And for summation, this formula was used. Summation to n terms, that was n over 2. First term plus the last term. That means when you didn't have the last term, you plugged this there, you had this. N over 2 a1 plus n minus 1 times the difference, and that was n over 2 2a1 plus n minus 1 times the difference, That was the formula. Now let's see how can we write that into sigma notation. Now remember, we are summing to any terms. We are summing them to any terms. That means we can use this symbol. Summation of r terms from r is equal to 1 to any terms. Summation of r term from r is equal to 1, that means the first term, to any terms. The n term is written there, up there, equals to what? Now I will use this formula here. The last term is n, then over 2. Then we have 2. 2 times what? The first term plus n, but we don't know what is the number, the position of that n, times the difference between the two consecutive terms. Then if you take 2 minus 1, it's 1. So simplifying that, we are going to have n over 2, then plus n minus 1. So this equals to what? N over 2, then this will be n plus 1. You will see that this formula that we have obtained there, or after we have written that series in sigma notation, you will find that it has become to be the formula that is used to find the summation of first n terms. That means we are correct. Now let's see the second example. Now the second example tells us to express that in sigma notation. Now how can we do that? That means we have to sum. That means the second example tells us to express 1 plus 7 plus 17 plus 31 plus down to 2r square minus 1. We are to express that in sigma notation. Now how do we do that? That means we have to sum that part. That means summation of 2r square minus 1 from r is equal to 1 to n will be equal to what? Let's open the bracket by the use of sigma. Now we shall have 2r square, r is equal to 1 to n, minus summation of 1 from r is equal to 1 to n. Now 2 is coming out of the sigma notation. That means we are going to have something like that, from r is equal to 1 to n of r square minus summation of r is equal to 1 up to n of 1. Now remember the formula to find the summation of first n square terms, as I wrote before. This will be equal to 2. That means we have to write that formula there. That means we have to write there n over 6, then n plus 1, 2n plus 1. And all of that is multiplied by 2, as the 2 is out of the sigma notation, minus that will be from r is equal to 1 to n. That means we are going to have an n there. So we have to simplify that so that we can write that in sigma notation. So how do we simplify that? We can open the bracket, so it will be 1 over 3. 2 and 6 will be 1 over 3. And then multiplying that, we are going to have n square plus 1 times what? 2n plus 1. And all of this is multiplied by 1 over 3 minus n. Now let's use that part to simplify. So it will be equal to what? It will be equal to 1 over 3. Let me open the inside brackets. Will be 2 n cubed, and then we are going to have plus n square times 1. We are going to have n square, and then 1, and there was n, sorry. N times 2n, we are going to have plus 2n square, and then n times 1, we are going to have n. But remember, we are supposed to subtract with n. Then let's simplify. Inside there, we are going to have 2 n cubed plus 3 n square plus n and all of that is multiplied by 1 over 3. That means if we write like this, and that means equals to what? 2n cubed, 3n square. All of this is over 3 minus n. Then this equals to what? If we try to add those fractions, it will be equal to 2n raised to 3 plus 3n square plus n minus 3n over 3. And simplifying that more, we are going to have 2n cubed plus 3n square, and we are going to have negative 2n, and all of that is negative 3. And all of that is over, we're going to be left with 2n square plus 3n minus 2. If we can find the factors of that quadratic equation, then we can simplify more. And we can simplify that by, then it will be n over 3. And then there will be 2. The factors, the numbers are 4n minus 2. I do hope you understand that. N over 3. Then we can factor out 2. And then we'll be left with n plus 2, and then factoring out negative 1, we'll be left with n plus 2. And then finalizing that quadratic will be n over 3, then 2n minus 1, n plus 2. Now let's finish up that question. That means the series 1 plus 7 plus 17 plus 31 plus down to 2r square minus 1 can be written in sigma notation. That means as a summation of what? Of 2r square minus 1 from r is equal to 1 to n is equal to what? Is equal to the thing we have obtained there. It is n over 3. Then we have 2n minus 1, and then we have n plus 2. So that is how we write in sigma notation in case of the second example. Okay, now let's discuss the next example. And the next example says find the sum of the following any terms of the following of the series. And the series is 2 times 3 plus 3 times 4 plus 4 times 5 plus 5 times 6. Okay, now finding the sum to that series, and we are told to find the sum to n terms, that means we have to find the nth term of that series. And in order for us to get the nth term of that series, let's decompose that series into the following two parts. That means we shall have the first part that will consider these numbers, and the second part will consider the second numbers. Now let's go to the first one. That will be 2 plus 3 plus 4 plus 5. Now let's find the nth term to that, and then we will find the nth term to the second one, which is 3 plus 4, 3 plus 4 plus 5 plus 6. We shall find the nth term to all of that. Now checking the first one, you will see that this is the first term, and from the first term 1 was added so that we get 2. And going to the second one, this is the second term, that means as 2, and 1 was added to that so that we obtain 3. And going to that part also, it is the third term, that means it was 3 plus 1. That means we can say the nth term to this is n plus 1. Now let's check the next one. You will see that this is from the first term, and you will see that from the first term, that means if it's 1, that means a 2 was added. And this is the second term, that means if it was 2, that means the second term, then a 2 was added. Going to the third also, you'll find the same. Going to the fourth, you will find the same. That means it was the fourth plus 2. That means the nth term there, taking this as n, then we shall have n plus 2. Now, we can write the series above as 2 times 3 plus 3 times 4 plus 4 times 5 plus 5 times 6 plus down to n plus 1, then n plus 2. So that is the nth term. Now, from that part, then we are supposed to find the sum to that, That means we are supposed to find the summation of what now? Of r plus 1, as we discussed earlier, r plus 2, from r is equal to 1 to n. From r is equal to 1 to n. Now, let's open those two brackets there. That means we shall have the following. Shall have this to that is r square, and that is plus 2r, and that is plus r, and plus 2. Then from r is equal to 1 to n. Simplifying that, we are going to have a summation of what? R square plus 3r plus 2 from r is equal to 1 to n. And now we can open that by the use of sigma notation. So it is going to be, a summation of r square from r is equal to 1 to n. And we know that 3 will come out of the sigma notation. That means we are going to have a summation of r from r is equal to 1 to n plus summation of 2 from r is equal to 1 to n. After reaching that point, we can see that there we have a summation of r square terms, and there we have r, and then we have that. That means we are supposed to use the formula to find the summation of n square terms. That is n over 6, n plus 1 to n plus 1 plus 3, and that will be the formula to find the summation of r terms. First, n terms is n over 2, n plus 1 plus 2n. Now, reaching that point, we are supposed to simplify that. And how do we simplify that? Let's simplify it. First, let's open the brackets there. That means we are going to have n times n, we are going to have n square plus n times 2n plus 1. All of this is over 6 plus 3. Then there we have, we are going to have n square plus n. That means we are going to have n square plus n, and all of that is over 2 plus 2n. Then let's simplify that more. Then we are going to have, opening the brackets there, we are going to have 2n cubic. This and that is n square, then 2n square, then plus n, and all of that is over 6 plus 3n square plus 3n, and all of that is over 2 plus 2, and all we know that that is over 1. Summing those fractions, what are we going to have? Let's say we have a 6 as LCM. That means we shall write that as it is. So we have 2n cubic plus, adding that part, we are going to have a 3n square plus n plus 6 divided by 2 is 3, then times that is 9n square plus 9n plus 6 divided by 1 is 6 times 2 is 12n. Collecting like terms, then we are going to have 2n cubic, 3 plus 9 is 12n square, n plus 9 plus that is 22n over 6. Let's simplify that more. can we factor out 2n is 2n? Then let's have 2n over 6. And inside the brackets, let's have what? That means we are left with n square plus 6. We factored out 2n. That means it will be 6n plus 11. And simplifying that more, that means we are going to have n over 3 n square plus 6n plus 11. And if that has factors, then you can write in terms of factors, and then that will be the sum to that series. Now let's conclude. That means the summation of what? R plus 1, R plus 2, from R is equal to 1 to n is equal to n over 3 n square plus 6n plus 11. So that is how we can sum that series. I will remind you from that example, 1 square plus 2 square plus 3 square plus down to the end term we are supposed to have n square. But there we have n minus 1, and all of this is squared. So how can you solve the example like that? It's fairly easy. Remember the formula to find the sum of square terms. It says summation of r square from r is equal to 1 to n equals to what? To n over 6, then n plus 1, then 2n plus 1. But remember our n there is n plus 1. That means you can let that equals to n. In other books, they just let that equals to capital N, and they put their capital N, and then they replace that with n plus 1. But we can go direct, and then n minus 1 over 6, n plus 1 minus 1. Then we have 2 n minus 1 plus 1. That means it will be n minus 1 over 6, and then there we have n, and then there opening the brackets, there we'll be having 2n minus 2 plus 1, that is 2n minus 1, 2n minus 1. And writing that in a simple form, it will be n over 6, n minus 1, 2n minus 1. That will be the summation from r is equal to 1 to n of what? Of r minus 1 square. So don't confuse or don't get confused. It's fairly easy. Let's see the next example. Okay, I will just explain this example. Now, we've been given the terms like that in fraction form. How are we going to find the sum of that? How are we going to find the sum of that series? It's fairly simple. We have 1, 2 times 3 plus 1, 3 times 4 plus 1, 4 times 5 plus 1, 5 times 6. That means we have to find the nth term. Now, finding the nth term, as we did in the previous example, we have to find 2 times 3 plus 3 times 4 plus 4 times 5 and so forth. That means let's extract these first ones. We have 2 plus 3 plus 4 and so forth. There we had a 5 and so and so. Now, how will the nth term be? This is the first term, but we have a 2, and this is the second term, but we have a 3. That means we can say it's 1 plus 1. If this is 1, then plus 1 will be 2. If this is 2, then plus 1 it will be 3. If this is 3, then plus 1 it will be 4. That means the nth term there can be will be n plus 1. And let's go to the second part. That means taking 3 plus 4 plus 5 plus 6. So how will the nth term be? If this is the first term denoted by 1, how much was added? A 2 was added. That means if we take a second term and put it there, that means it will be 2 plus 2 which equals to 4. And on the third term, if we take 3, that's the position of that term, the 3, plus 2, it is equal to 5. And the fourth, that means the fourth term the position is 4. That means if we put 4 plus 2 is 6. That means the n term there will be n plus 2. So we can write the nth term there to be n plus 1 and then n plus 2. So to find the sum of that series, we have to write that in sigma notation. So let's write that in sigma notation. That means we have the sum of, if we put there r plus 1, r plus 2, as r equals to 1 to n, equals to what? We have to find the sum of that. Now, to find the sum of that as it is, we have to partialize, as we did in the previous example or the previous lesson. We did partialize so that we can simplify a function to simple parts. Now let's partialize this into simple parts. Now how do we partialize that? That means we have to write there 1 over r plus 1, and then we have r plus 2, and the rules says if you have two distinct roots, then you are going to have something like this, plus b, then r plus 2. Now let's simplify that. It's fairly easy. We have a r plus 2 plus b r plus 1, and all of this is over r plus 1 r plus 2 and is equated to the left hand side, that is r plus 1 r plus 2. Let's simplify more. That means the denominator will go. That means we'll be left with 1, which equals to what? 1, which equals to, I'll open the bracket directly. It will be a r plus 2a plus br plus b, and collecting the terms, the constant and the constants, and the coefficient of r to coefficients of r. That means we are going to have a plus b, a plus b. It does not have something to compare there, then it's equals to 0. And the second one is 2a plus b equals to what? Equals to 1. So we are supposed to solve those two equations so that we can obtain the value of a and the value of b, as we did in the previous lesson. Now, if we subtract that by elimination, what are we going to have? This we are going to have a negative a, and b minus b equals to 0, and 0 minus 1 is equal to negative 1, and then a will be equal to 1. And then finding the value of b, let's multiply the equation above by 2. Then we are going to have a 2, or let me write so that we can understand each other. So we are going to multiply there by 2, and then by this will be multiplied by 1. So we are going to have a 2a plus 2b, which equals to 0, then a 2a plus b, which equals to 1. And then subtracting those, 2a will go, and then we'll be left with what? With b, each equals to negative 1. So this can be written like the summation to what? The summation of r plus 1, r plus 2 from r is equal to 1 to n, which equals to what? To the summation of a was 1, and this is r plus 1, and b is negative 1, from r is equal to 1 to n. Now let's try to check when r is equal to 1, it implies, what are we going to have there? When r is equal to 1, that means putting 1 there, that means we are going to have 1, and that will be 2. We're going to have 1 plus 1 is 2, minus, putting 1 there, we are going to have 1 over 3. And when r is equal to 2, it implies putting r is equal to 2, that means we are going to have 1 over 3 minus 1 over 4. And when r is equal to 3, we are going to have 1 over 4 minus 1 over 5. But you will find that these are the same. So we can go down to when r is equal to n minus 3. N minus 3. So let's put n minus 3 there. That means we are going to have 1 over n minus 3. That means n minus 3 plus 1. We are going to have n minus 2. N minus 2 minus, so let's put there 2. We are going to have, so we are going to have n minus 1. When r is equal to n minus 2, n minus 2, that means we are going to have there 2. That means we are going to have n minus 2 plus 1, that is n minus 1, minus 1, and then minus, and there is plus 2, we are going to have 1 over n. And when r is equal to n minus 1, what are we going to have? N minus 1, that means we are going to have, if you manipulate that much correct, will be n, then minus, n minus 1 will be 1n plus 1 from there. Now, and when r is equal to n, we are going to have 1 over n plus 1, and then there will be minus 1 over n plus 2. Now, you will find that if we try to add all of this is negative and that is positive. That means this and that will go. So as this and that. That means all the terms that are in between there will go. And let's go to that part. This is negative, all of this is negative. Negative 1 over n minus 1 is negative, and this is positive. That means adding the terms, this and that will cancel to each other. And also this and that one. So as this and that one. So we'll be left with summation from to n of what? R plus 1 equals to what? We'll be left with a half minus 1 over n plus c 2. And simplifying that, we are going to have, adding those, we are going to have n plus 2 minus 2. Then we are going to have 2 and 2 goes. We are going to have 2n plus 2. So this is the summation of 1 r plus 1 to n. And the result we obtain is the summation to the above series that was there. So this is how we sum such kind of series. So let's solve the next example, and I will explain one thing last one. So the example says, prove that this equals to that. The left hand side equals to the right hand side. The procedure to follow will be the same as it is. But in this example, we were given the nth term, and then we are told to find the sum to infinity. So I will elaborate how to find the sum to infinity when n is equal to infinity. So I will elaborate that. And the example says, prove that the summation of 1 over 3 minus 2 in brackets times 3k plus 1 in brackets from k is equal to 1 to n is equal to. So we have to prove the left hand side is equal to the right hand side of that example. And then we have to find the sum to infinity to that. 3n plus 1. So the series has been written in sigma notation, so we are supposed to prove that this left hand side is equal to that right hand side. First of all, partialize this part. So we have 3k minus 2, 3k minus 2, 3k plus 1, and the rules say we have to write there a over 3k minus 2. I do hope you remember the previous lesson about partialization. Plus 3k plus 1. So let's find the values of a and b. Then we are going to have a 3k plus 1 plus b 3k minus 2. All of this is over 3k minus 2, 3k plus 1, 1 over, and it is equated to 1 over 3k minus 2, 3k plus 1, 3k plus 1. So I will open that directly. We have 1 which equals to 3ak plus a plus 3bk minus 2b. If you can't open directly, please just follow the rules and open that. So collecting like terms, there we are going to have a 3a plus, that means a 3a and that, this one and that with k, which equal to 0. This is implies that a plus b equals to 0. And then the constants are a minus 2b equals to 1. That means this is our first equation and this is our second equation. We can use those two equations to find the value of a and b. And let's practice the calculator uses. Let's practice the calculator uses. We go to equations, and then the equations have two unknowns, and the first coefficient, the coefficient is 1 plus 1, and a constant is 0. And the second equation, the coefficient is 1 and negative 2, and the constant is 1. Then a equals to 1 over 3, and b equals to negative 1 over 3. So let's write that in series. We are going to have, that means the summation of 1 over 3k minus 2, 3k plus 1 equals to what? The summation of the following. In partial fraction, that means this will be 1 over 3. Then 3k minus 2 but b equals to -1, that is 1 over 3k plus 1. And this is added, when r, when k is equal to 1 up to n. So let's do this as we did in the previous example. When k is equal to 1, it implies that we are going to have 1 over, there we are going to have 3 times what? Times, we're going to have 3 times 3, if you put there 1 will be 3 minus 2 is 1. Then minus, if you put there 1 will be 1 over 3 times, putting there 1 plus, that will be 4. And then when k is equal to 2, and then when k is equal to 2, it will be 1 over, then putting 2 there will be 6. 6 minus 2 is 4, that is 3 times 4, minus, and then there putting 2 will be 6 plus 1 is 7, that is 3 times 7. But be careful. So if this and that resembles, that means this will cancel that one. So as the rest of the rest of the series. Now let's go to where it ends. Now let's go to when k is equal to n minus 2. Let's say when k is equal to n minus 2. When k is equal to n minus 2, it will be equals to what? So we have a 3 times what? So putting there, it will be 3 n minus 2 minus 2. Then we have 3n minus 6 minus 2. So we have 3n minus 8. So we have in brackets, we can put that in brackets so that it can look nice. 3n minus 8 minus, so there we have plus 1, so we can put just replace that plus 1, it will be minus 5, so we have 1 over 3 times 3n minus 5. And let's see, when k is equal to n minus 1, it implies that we have 1 over 3 in brackets. Let's find the inside the brackets. Then we have 3 n minus 1. That means minus 2. 3n minus 3 minus 2. That means 3n minus 5. Minus 1 over 3 in brackets. Let's find, it will be 3 plus 1, then 3n minus 3 plus 1, 3n minus 2. And then when k is equal to n, what are we going to have? 1 over 3 in brackets, it will be 3n minus 2 minus 1 over 3n plus 1. As you can see here, my dear student, this resembles to that. So as will the remaining there. That means if we try to add all of this, will be this and that. This is negative and this is positive will go. And so as the rest ones. And then this one resembles to that. But this is negative and that is positive. That means this and that will go. And then also this is negative and that is positive. So this and that will go. That means Adding all of those, we are left with this one and the negative this one. So let's add those. We are going to have 1 over 3 minus 1 over 3, 3n plus 1. Let's add those fractions. So we are going to have a 3 plus 1. Then trying to find the sum there will be 3 n plus 1, and finding the sum there will be equal to what? Let's write there will be 9. This times that is 9, 3n plus 1. There will be 3n plus 1. There will be 3n plus 1 minus 3. So if we open the brackets, there will be 9n plus 3 minus 3 over 9, 3n plus 1. So this and that goes, and then we say that that 9 will cancel with that 9, and we are left with n over 3n plus 1. And you will see the results that we have obtained there is equal to the result that we are given to the equation. But the question said we have to find the sum to infinite. We have to find this. First we are to prove, and then to find the sum to infinite. Now let's find that sum to infinite. And you will use that to other question that says the sum to infinite. Now that is the sum. That is the sum of that series, as we have proved by the steps. So we'll divide with someone can start from this step, or someone else can start from that step. It's the same. So let's divide by n throughout. That means we are going to divide by n over n on top, and down here we are going to divide by n, then by n. That means on top there we are going to be left with 1, and then down here we are left with 3 plus 1 over n. But remember, we are told to find the sum to infinity. That means we have n 3n plus 1 when n is equal to 1 to infinity. That means when n is equal to infinity. Now writing that there is equal to 3 plus 1 over n. Putting infinity there, that means we are going to have 1 over 3 plus 1 over infinity. And this is what? This is 0. That means we are going to be left with 3 plus 0, and that is 1 over 3. So this is the sum to infinity. This is the sum to infinity. So that is how we solve such kind of questions. So my dear students, please keep on practicing, and I assure you, you will learn much more as you practice. I will leave you some few questions for you to practice. Please do them and find other questions to do. So my dear student, this is how we find the sum to infinity. So please find more questions and perform them, and I assure you, you will perform much better in your exams if you keep on practicing. So practice makes perfect. Until next session, you were with Sir Kimati from Jangwani Secondary School.